Okay, I'm going to try doing another one of these for, what is it this time? Maybe sequences and series, because um, it won't matter to you when you're watching it, but at the minute, basically, what's happening is a lot of the sixth years are going through the final part of sequences and series that they're going to come across, and I can kind of see that they're not too great with it. I don't know if they've gone over it properly. Everyone keeps seeming to do it in weekly classes, as in like the one they have before or after school, once a week, and it just seems very disjointed. So it seems like it's one on like, at present, it's just very important in my mind. But I guess I'm just gonna talk about it now. I said the 6 years, but it is in well, it used to be in the junior cert course. They've changed the junior cert course so much now, I'm not entirely sure what's what anymore, but we'll see. Based on the old stuff, for now, no, you do need it, but you don't. I don't know to what extent. Basically, yeah, we'll still wait and see. But in the basically in the secondary level, in secondary school, in secondary school level maths, there are three types that you have to take into account. Um, yeah, how do I do it? Like, so arithmetic. Now that word is pronounced arithmetic, even though it's spelled arithmetic. It's two different words or something pronounced different. I don't know. But we call it arithmetic in this context, and arithmetic when we're dealing with quadratic. I spelled that wrong. When we're dealing with like actual numbers. Arithmetic, quadratic, and geometric. Those are their fancy names. Now, in these two scenarios, we will very often refer to arithmetic as linear and geometric as exponential. Those are two different, like, just kind of like nicknames, street names for these guys. Exponential. The two red ones will be what they show up as in the like log tables, for example, and in books and exams and all sorts of crack. But that is what I might call them. I might call them either linear arithmetic or exponential geometric. Just keep that in mind. Now the way it works is, I think you need both of these if you're doing junior cert or leaving cert ordinary. So either of the junior certs, but if you're doing ordinary level in the junior cert, you need those two in the green circle. If you're in honors, you need all three. So if you're doing honors in leaving cert, you need all three. Otherwise, you just need the first two. And I'll probably do it in order like that because it kind of goes in this direction. Well, yeah, it goes in this direction of kind of like difficulty as well, so it might be what I'm going to be doing anyway. But an example of an arithmetic sequence would be 3, 5, 7, 9, 11, and it's just that an arithmetic sequence is a sequence, a list of numbers where the numbers go up by the same amount each time. So basically what you can do in an arithmetic or linear sequence is you can just do loops like this. And what's the difference between 3 and 5? It is 2. Difference between 5 and 7, it is 2. 7 and 9, it is 2. 9 and 11, it is 2. And it's arithmetic or linear if the first layer of numbers are all the same. Now, there will be other scenarios. Now, I'm going to show you that basically these can start off the same. Because they, like, both of these start with a 3 and a 5, but the difference between a linear and a quadratic is the first layer of loops wouldn't be the same. So, for example, this could be 9. Do I want to do? Yeah, I'll do it for this. But it'd be 9, and then it would be 15, and then you're adding on, so it'd be 23. Because when you do your first layer loops here, hopefully I've done this right, you'll notice that the differences are not the same when you take them all away. So what you do is you actually do a layer of loops, or a layer of differences for the first layer of differences, and you'll notice that in this scenario you're adding on two each time. So in arithmetic, it's the first layer is all the same. If the first layer is not the same, you then do the second layer and go, oh, it's turns out it's quadratic. Now in exponential, I know I said I'm going to do these in order. I'm just kind of like giving a preface to all of them at once. But I will tell you, if you're here for ordinary leaving cert, or if you're doing junior cert maths, you won't need this one. I am going to write it here though, and then go back to one of the other guys. I just want to have all three kind of labeled at the start, so I'll have something to reference back to. Geometric would be something, for example, that is like 3, 9, 27, 81, 243. And the way that works is, again, we just do the first layer of differences, and we'd see what it is. 6, 18, 54, 162, I think. I'm always afraid I'm going to do some mistake in this, and these are all going to be like, oh, yeah. But I don't know if any of you are paying attention enough to actually notice. 36, and what would this be? 108. Yeah, I think so. But you'll notice that in this scenario, neither of the layers match up, which is fine. Now, you do not need to do any more in leaving cert level. If you wanted to go into cubics, there would be now more and more layers. But in leaving cert, if it's not these two, you just literally say, oh, that means it's exponential or geometric, and that means that you'll notice it's multiplying by a number each time. Instead of adding on a number, like in the first one, in linear version, we're multiplying by a number each time. In this example, I multiplied by 3, because to get from 3 to 9, you're tripling it. 9 tripled is 27. 27 times 3 is 81. And 81 times 3 is 243. Again, junior cert and ordinary level in leaving cert do not need to worry too much about that at all. You need to know the name of it, because sometimes what they'll do is they'll kind of say, what type of sequence is this? That's the extent of geometric or exponential getting in those two, if you're not doing honours leaving cert. And all you would do is you do your first two layers and you go, well, neither of them match, therefore it's exponential, or it's the other, or whatever they say, right? If it's not arithmetic quadratic, you can just say it's exponential, and that's the extent. Honours leaving cert, you kind of have to realize that is a number that's being multiplied each time. Now, what way do I want to do this? I'll probably want to talk about linear, because again, that's for everybody. Quadratic is probably for everybody. Quadratic was one of those ones, just to note for leaving cert people, that they were kind of leaving it out of the honours exams, because they were putting in, because in honours they can only ask the let me rephrase that. They can only ask the exponential one in the honours. They couldn't ask the exponential in the ordinary or in the junior cert, so they kind of took advantage of the fact and used it whenever they could in the honours one. And then resorted to doing quadratic and arithmetic more so in ordinary level. But to the honours students, like, I'd just be worried that in recent years, a few of the things that were just kind of people took for granted weren't going to show up in the honours have started showing up in the honours, and they're trying to catch honours students out for not doing the course that technically the ordinary level students do and the honours students should do, but the honours teachers were kind of like taking liberties and leaving them out. So technically, people don't do this a lot in honours, but I'd just be afraid. But for now, I'm just going to look at this real quick. Now, I don't think I did do the thing yet. Basically, I have the formulas that you need in this topic on page 22 of your log tables. And you'll notice that it has two sections. It has the arithmetic section here, and it has the geometric sequence here. So you'll notice, if you're paying attention, that there's no quadratic section in the middle, and that is the way it is. I don't know what to tell you. So for the arithmetic sequences, there are 2 formulas, and for the geometric sequence or series, there are 3 formulas, and we'll talk about them all in a second. But before we get into doing all of this, I'll explain the idea of Tn and Sn. It kind of highlights it up here, but Tn is basically a way of coming up with a mathematical formula that will tell us what the nth number in the list is. So for example, if I wanted to know what the 63rd number in the list is, I would find out what T63 is, and that basically means wherever I see n in the formula, if we make one, I will replace it with a 63, and then hopefully, if I've done everything right, if the maths is correct, if the formula is right, it will tell me what the 63rd number in the list is. So that's Tn. It tells you what the nth number in the list is. Sn will tell you what the first n numbers in the list add up to. So just for an example real quick, in the linear section that I have here, that's 3, 5, 7, 9, 11. If I put in T3, if I found out what T3 is, I haven't gone into it just yet, but if I did T3, it should tell me 7. It should say, oh, T3 equals 7, because t represents the term and 3 is the third one, so it represents the third term. If I did S3, what it would actually do is it would add the first three numbers together for me, which is 15. Now, looking at that, you'd be like, well, it's just easier to do that than do the formula, which is obviously true, but in the actual maths, they will ask you to do more than just those three numbers. So we want to make sure that to do this way, because otherwise I've seen horrible cases where people it's not that they go into it trying not to do it, but they forget how to do the formula, and then they try to do it that way where they just add all the numbers up. And I have seen entire pages full of 11 plus 14 plus 17 plus 20 plus 23, all the way down, like a full A4 page of that, and you don't want that in your life. You get full marks for it technically, but good lord, you don't want it. So that is what TN is, that's what SN is. I've kind of highlighted what all the three different sequences you'll see are what they look like. So now I guess I'll just real quick kind of highlight how to use these formulas. I'm going to do it for the arithmetic version real quick now. So basically what you do is, I forgot to mention the letters in this. The letters in this, other than the N and the T and the S, which we've kind of already highlighted, where N is T is what term it is, S is what the first terms add up to, N is which term you're talking about. Like, for example, when I did T3, I was talking about the third one. When I did S3, it was the first three. The A and the D, A is the first number in the list. So for me, here, that would be this 3 is the small a. That is a small a. And D is the common difference. So this would be the D, because it's how much it's different by each time. And it's common because it's the same number each time. Somebody criticized me today about my N's, I think, how I wrote my N's. So I'm just kind of on edge with my writing. That A doesn't look fantastic, so I'm conscious of it. I'll try my best, don't worry. So what I would do to find the TN for this specific list of numbers, this 3, 5, 7, 9, 11, if they give you a different list of numbers, it's going to be just a different TN altogether. What you would do is you would just do TN equals, and then I'm going to write down the formula here just so you can see exactly which one I'm doing, but it's just in the log tables, it's fine. And you just sub in the relevant letters. So for A, I'd put in 3. Now N I'm going to leave for now. D I'm going to put in as 2. People don't like the D at the end. People prefer the D here because then you're more used to having a number in front of the bracket, but it's fine having it at the end. So I like to put it in a bracket just to highlight to you that you are multiplying it, because people would see like this and be like, what the hell is this? So just kind of, it's the exact same thing. You don't need to write in the brackets, but if you want to have it not look as alien to you, that's fine. You can do that too. But I'm going to multiply the 2 by the n and then the 2 by the minus 1. So I get 2n minus 2, just literally multiplying in like that. Obviously you're more used to multiplying in the other way where the 2 is at the front, but it's all gravy, it's all the same thing, don't you worry about it. And then here we do like terms of 3 and minus 2, and we get 2n plus 1. So if I've done the maths right, that should be the TN formula for this list of numbers, and that would mean that this should be a formula that will tell me whatever the nth term in that list is. So just to practice, so up here I highlighted that T3 is 7 because the third number in the list is 7. So if I now take this formula and do T3, and basically what that means is take the answer we got for Tn, and everywhere we see a 3 or an n, put in a 3 in brackets. 2 times 3 is 6. 6 plus 1 is 7. Wow, isn't that crazy? That's amazing. So that's what the T formula does. It just tells you what the nth number will be. And again, you're like, well, for the third one, we can see it, it's in the thing, whatever. If it was just the 7th, I could just like actually do it out myself. And you can, and that's fine. But in certain exams, they will ask you for what like the 47th number is, and you don't want to have to make the list 47 long to do all that crap. It's just a mess. Now I'm going to do the exact same for the SN formula for the linear version. I'm just going to literally take this formula from here. And again, the whole point of this is, the 22 is kind of in the middle there, so I'll probably avoid that. The whole point of this is it should give us a formula that will add the first n numbers together for us. That's all. While I'm doing this, I just want to highlight that I am aware that the last video I put up, the trigonometry one, the second trigonometry one that's just for honor levels students, I'm aware that it was quite long, and I know I've been kind of getting a bit more into it's kind of gotten away from me, where I was kind of in at the start trying to make this where it was just like, oh shit, do this if your exam's tomorrow. But I kind of got a bit, I just enjoy the maths. I just got into it, and I just started doing more and more bits and pieces to it, and it just kind of got longer and longer. I'm conscious of it. I'm trying to keep them short. I'm trying to keep them like concise. I just genuinely enjoy it, and I genuinely think there are bits you're missing, and that I'm trying to give you as much as I can. That's all, right? I know he's all giving out. I don't want to watch, what was the last one? 106 minutes of you doing trigonometry. I get that, but look, it's your exams. You only have a few more days of it, I'm sure, at this point, because you aren't watching this before. Well, some of you might, but I imagine the majority of people are watching this like the day before, a couple of days before the exam. You're just going to have to grin and bear it for a few more days, a couple more weeks maybe. I don't know when you're watching this. But the idea again is here, I'm going to also just leave n as is, and then instead of the a, put in the 3 again, because remember we said that a is the first number in the list. Yeah, leave n as it is, I said, in D, but in 2 again, because that is what we found. Now, as I said earlier, if it's a completely different list of numbers, you'd have a different A and D, and you'd be subbing in different numbers. People don't like this one because the algebra gets a bit wild. 2 times 3 again is 6. You multiply the thing in, you get 2n minus 2. Inside the bracket then you would get 2n plus 4. Now, you can leave it at that, and you can use roundy brackets instead of the square brackets. They only put in the square brackets in the formula so that you wouldn't get them confused with the round brackets. It'd be like, which one closes which? But like, no one ever would do that. So they're interchangeable with round brackets. They don't mean anything different. Technically, they're just the brackets. These round ones are parentheses, right? But what you can do, and I'll do it in blue, I'll do it in red to highlight this isn't like necessary. It's just kind of like an option. What you can do is anything can be made into a fraction by putting it over 1. And then really what you're doing here is multiplying 2 fractions together. So what you would do is you would do top by top, bottom by bottom, because that's how you multiply fractions. N by 2n is 2n squared. N by 4 is 4n. And on the bottom 2 by 1 is 2. Now, you could leave it like here as well, but what you could then do is divide all the numbers by 2 and get n squared plus 2n. And that would be the final form of it, let's say, but then this would be, this bit in green here was perfectly fine. Yeah, but I'm going to go with the red one if that's okay. The green one would work out the exact same. It's okay. All I'm going to do is do S3 again to prove that it works. And hopefully I do get 15, because the first 3 numbers there do add up to 15. So if I do, it's kind of cramped, but if I do S3, basically in my formula down here, everywhere I see an N, I'm going to replace it with a 3. And I will do this. And we would get 9 plus 6. Which is 15. Wow. Congratulations. So again, that's what the SN is for. It tells you what the first n numbers add up to. If I put in 3, that's fine. I just tell me what the answer is. And that's the basics of this. I will point out that for linear and arithmetic, some of the teachers avoid using the log table formulas, and I really don't understand why, because they're right there in a book and you just fill in the letters. Some of them do this thing of like, oh, well, if the change is this, what really you can do is do the first number plus the change multiplied by the... Like, they're basically reconstructing the formula, and I don't really understand it, because it would make sense for maybe me or the teachers to do, because we do so much of this all the time that it would just be quicker. For you guys, it's not that you're stupid, it's just you have 8 subjects or something to do. You have a social life where, we have, enough time to be doing maths again and again and again that we're going to know to do this, and we're going to find shortcuts. There's no real point for you guys to find a shortcut, because you're not only are you not doing that much maths, but it's an extra, just remember to do this, and you have a lot of that already as it is. So I really don't understand why they don't just do this. It's in the log tables. Maybe someone can highlight to me. One of them will, say, oh, it's because of this, and I go, oh, I never copped. But I really don't get it. Yeah, okay, so what I'm going to highlight here is something that can carry on for anyone who's here for more than just, I suppose for anyone here who's honours leaving cert as well. This kind of carries through to the further bit, but we'll get to that later. The idea is, though, in an arithmetic or linear sequence, if you want to find out what the difference is, you do, for example, the second number, take away the first number. Or you do the third number, take away the second. Or you do the fourth, take away the third. You always do a number, take away the number before it. Because that's kind of reversing the addition that would have gone forwards, if you follow me. We're doing minusing backwards. Yeah. So that's how here we know it was the 2, because, well, you see, the thing is, most people will go, well, I know 3 plus 2 is 5. You're not actually doing any subtraction. When we got the first 2 here, sorry, my tablet's not working, but when we got the first, when we did it 3, 5, 7, 9, 11, and I found all the differences here, there we go. When I found the 2's there, it wasn't so much that I was doing 5 minus 3, it's just like most people, I just kind of went, well, I know 3 plus 2 is 5. But when it gets to harder numbers, you want to be able to know that what you would do is you'd always do a number minus the number that comes just before it. And that will tell you what the common difference is. It will tell you what the small letter D is in this context. Okay, is there any kind of notes I want to say on that? I don't know. I don't think so. Well, I'll tell you what, I'll just do the quadratic one, because anyone here for the arithmetic one also needs to be here for the quadratic one anyway, so it's not like if I remember them, I'll come back to it. If I don't remember and I turn it off and then go through it and go, oh yeah, I should have said this. This was kind of a spur of the moment kind of thing. I don't really plan anything out. I was just gonna. A few people were just kind of. I could see that sequences and series wasn't going well, and particularly in Leaving Cert honors, you needed to do financial maths. So I just thought it'd be something good to get out of the way. Now, as I said, for quadratics, there is no formula for it. I'm so sorry. We're going to have to do this by hand. And the way it works is, a quadratic, you will have heard of the word quadratic because it would have been for the minus b formula. The minus b formula is what we do on any quadratic. Some people like to still do the brackets or whatever, or the guide number, whatever you're into. But any quadratic normally that you're used to will look like this. The only difference is in sequences and series, what we do is we change out the letter X for letter N. That's all. Where the N represents what number in the list we're talking about, like with the Tn earlier, right? So this is actually what the Tn formula for quadratic looks like, and you will not have to generally come up with an Sn formula for it at all. So that's fine too. In honors, they might pull some bullshit that accidentally finds the Sn. They sometimes in honors will do, or not in honors, just in any exam, they will sometimes throw in a question that they kind of want you to learn something new about maths on the spot, which is just kind of a bit stupid. But so, like, they're kind of hoping that you'll do a thing and go, oh wow, that's how you get that, like you care, like it's at that point you need that, it's your leave and you have your own stuff going on. But for quadratics, yeah, so every Tn has to look like this, and our job is to find out what the A, B, and C are, the unique A, B, and C are for, let's say, the list that they give us in the question. Let's say it's 3, 5, 9, 15, and 23. We've already established it's quadratic because of our double layering, so that's fine. So what we're going to do now is, our job is to find A, B, and C. A is by far the easiest one to get, and it's one that we're going to get straight away before we do any maths. A is always half of the second difference. So the layer of numbers that were all the same, that affirmed, you know what I'm trying to say, kind of proved to us that it is quadratic. We need to get half of that number, and that is what A is. So because it's 2, half of 2 is 1. So literally, I know that in place of the A, I can no maths done, just stick a 1. Alright, and that's just like immediately how we like. Now, unfortunately, B and C, we're not going to do that smoothly at all. I'm sorry. It's going to turn into simultaneous equations. I know a few of you don't like that, but that's, nothing that we can do about that. Yeah, now I put in the 1 there, but don't forget now, in a way a mathematician will write that, the way it will come up in the exams and in the book, they won't write the 1 there. They'll just leave a blank space, if you remember, because 1n squared is the same as just n squared. That's all. Now our job is to find B and C. A lot, not harder, just a lot more work to do. So the idea is, because it's Tn, we wanted to work that when we pick the nth number, let's say 17, and we put it in everywhere we see n, we want it to give us the 17th number as the answer, which is what we want in the long term. It doesn't really help us now because we don't know the 17th number in the list, and we don't know the B and the C that would help us find that. So what we're going to do is we're going to resort to the numbers that we do know. So for example, we know that the first number is 3, so we know T1 is 3. So we know that if we put 1 in everywhere we see n here, we want this to work in a way that the maths will give us 3 as an answer. So I'm going to set that up. I'm going to say, well, if I did know B and C, let's just pretend we did know B and C. This is how we'd find the first term. We would do this, because that is just the formula up here, filled in, where everywhere I see n, I put in 1. And I know the first number in my list is 3, so I want that to work in a way that it will give me 3 as an answer. Then, just do the maths. 1 squared is 1. B times 1 is B. C is 3. And I'm going to bring the 1 across using algebra, make it a minus. So we end up with B plus C equals to 3 minus 1. And then B plus C is equal to 2. I'm trying to think ahead whether I did numbers that are going to work out weird, but we'll see. We live in hope. Now, we are going to box this guy off and come back to him later. So the idea is that, you notice there are 2 letters there we don't know, the B and the C. However many letters you don't know, you need that many equations to figure it out. That is 2 letters in 1 equation, so we can't physically figure it out. So what we're going to do is we're going to make a second one, because if there's 2 letters, we need 2 equations. Now what I'm going to do is, and it's you don't have to pick the first 2. A lot of people pick T1 and T2 because of the smallest number. It's easier to do. I will use, I'll use T2 anyway, I suppose. But I promise you, if you'd done T3 and T5, this would have worked out just the same. In the long run, it'll just be all the numbers are a lot bigger. But everywhere I see n in the original guy, I'm going to put a 2 now instead. And because I'm putting in 2 into the Tn formula, I want it to give me the second number in the list as an answer, which is 5. So I want this to work in a way that it does give me 5. So that's what I want to happen, but we're going to have to see what the B and C are going to have to be in order to make that occur. But you'll notice all I'm doing is multiplying the shit out, bringing the 4 over, making it a minus on the other side. Yeah, and then 5 minus 4. I will also point out that the last video I put up, I know you're not necessarily watching these in chronological order, like one after the other in order if I put them up. But the last one I put up, the one that I said in the title, it was honors only, no ordinary allowed or something. And because it's not for ordinary, but I don't think anywhere in the video I said that. So I was just kind of frantically afraid that some ordinary students would watch that thinking, because, oh, I have to do trigonometry. And they'd be wasting like an hour and 46 minutes of their life watching trigonometry that they don't need. So I was trying my hardest just to point out, I was afraid that if I wrote it at the end, it wouldn't come up in the thumbnail kind of bit, and you wouldn't see it until you were in the video, and then you're not going to look at the heading or the description or anything. So I was trying to get it out there as fast as I can. People were accusing me of discrimination, wanted me to do an apology video. No. But yeah, just to kind of I don't know, kind of mention that again. As I said, I'm aware they're all very long. I'm aware that it's not the most fun thing you could do with your spare time. I'm aware of that. But here, because we have 2 equations that have the same 2 letters, what we have to do is we have to do simultaneous equations. I know. 50% of you have said, oh, class, I can do these, and 50% have said, I hate these things with a passion. I'm not going to focus too much on this, because this is something that will I will hopefully do. Oh no, I did do a video on simultaneous equations. I think I did. So if you're stuck with simultaneous equations, just go back to that video. I'm just going to fly through this if that's okay. Well, it is okay, because like I said, I guess, because you don't really have a say in what I'm doing now. But basically, you have to do simultaneous equations to find the B and the C. The A is by far the easiest number to find, as we said, because what happened was, or the A just has its own little quirk to figuring out what it is. I will point out that when you're doing this now I said I wouldn't really focus on the simultaneous, but when you're doing this, the way it works is the plus C will always, no matter what T you use, it will always be a plus C at the end. So it's just a tip, I suppose. In these, always just multiply one of them by -1. I like to pick the one with the the smaller b term, it literally makes no difference though. Just pick one to multiply by -1, because then what you'd get is minus b minus c equals -2. And then you'd have 2b plus c equals 1. But if you remember, in simultaneous equations, the whole point is we want one of the letters to cancel, and if you just change one of them to a minus, the plus c and the minus c will cancel. 2b take away b is b, -2 and 1 is -1, so b would be 1, or -1, sorry, and then whenever you want to find the second letter, you just sub it into one of the original ones. I'm going to take the first one of b and c plus 2, but everywhere I see the b, I'm going to replace it with a -1. Bring the -1 over, it becomes a plus, and you get c is equal to 3. Now, those are our b is -1, c is 3 apparently. I can't wait to see how I've scuffed this up. But then up here, what I'm going to do is change that to n minus 1, n plus 3, isn't that what I said? B was -1 and c was 3. So what I did was, where it was a b, I put in a -1, and you can put a 1 there, but don't forget that we won't write it like that. So you can write it, that's fine, but we won't write it like that. So just be awares, and then c was just plus 3. So that is the formula that should be the Tn for this specific green list of numbers here, and we can prove it. This isn't part of the actual exam or question or how to do it, but let's just say I wanted to make sure I was, I have time extra, and I'm just kind of curious to see if I'm right. I'm going to do T4, and I'm going to sub everywhere I see an N, I'm going to put a 4, and what should happen is I should get the fourth number in the list, which is 15, and you notice that 4 squared is 16, minus 4 is -4 plus 3, that would be 12 plus 3, which is 15. Wow. Now, that is, again, that's not hugely necessary. I'll leave it there now, I suppose. It's not hugely necessary. It's just for yourself. They will only ask for this bit here, the end, like the actual final answer, because don't forget that bit is the actual final answer. They'll ask for the 2 that you subbed in. Again, it doesn't have to be 1 and 2. It could be like 3 and 4. It could be 5 and 2. It doesn't matter, as long as they're ones that you have in the list. And they will look for the simultaneous equations. That's what they'll look for there. Now, I haven't decided how I'm going to do this. I don't know if I want to... I'll put a cut here so that if you are not doing Leaving Cert or Leaving Cert higher level, you don't have to look through this if you don't want to. But I will do basically the exact same for those two, for the TN and the SN and the S Infinity. I know big things ahead for the geometric series or the exponential series. And then I might try to look and see if there's anything else I kind of want to highlight to do with this. There's another thing in honors we have to do in Leaving Cert where they sometimes will give you a sequence that isn't one of these three. It's just kind of some arbitrary thing they made up. But we'll see, we'll see. Okay, I don't know how much space I left in between me like stopping talking in the last part and pressing like the cut video and then pressing the button here and starting again. So to you guys, I might have jarringly just immediately started talking after stopping, but that's just, yeah, sorry, I don't know. I'm figuring this out, shut up. So, there's one thing, in that gap I had there, I actually went and I looked at the junior cert, the new junior cycle curriculum, because they have changed it, and it doesn't seem, that there's not as much, I don't think, as the old curriculum on what is necessary. I'm not saying there's not as much on the course, well, there isn't, because there's only one exam. There can't really be as much, but it's just not as precise, I don't think. It just kind of says, like, you know, it for junior cert, it basically says you need to be able to construct the formulas, recognize which of the sequences they are, like quadratic, arithmetic, linear, be able to construct the TNs in those scenarios, and maybe they mention the SNs, I can't quite remember. But they're trying to make the maths course basically like, you know, oh, how do you feel about maths? Like, that's basically where they're going. So it's from what I can tell, I don't know if there's some grand master scheme going on in the background, but it does seem to be that they're taking away the maths and just kind of like the CBA nonsense and stuff. But I don't know if that's working. It might be better if they did it properly, but it's just, I don't know. But there is one other thing I want to highlight to everybody that I'm going to do here real quick. And then the junior cert people, I think, can piss off. And I will go down here and I will do probably an actual ordinary level honor cert, ordinary level leaving cert, sorry, exam question, just to give you a quick highlight. I'll just kind of breeze through it, but if you don't want to do that bit, I will tell you when I'm about to do it, or it'll become obvious when I'm about to do it. And I'm starting to put in, or I'm trying at least to put in these kind of place card things at different intersections. So what I will try to do is I'll try to remember to put one in. So if you're in honor level maths and you want to just skip that part, that's fine. You just like scroll forward till you hit the thing, and don't do the oh Graham, there's a way of doing it on YouTube where it shows up on the bar down the bottom. Yeah, I don't know how to do that. All right, so you're getting my best here. And then so when I get to that bit, the honors can scroll ahead, and the ordinary people can dip out, and and junior cert can just miss all of it. But this part you want to stay for everybody. Because basically what I did was I showed you how to find the TNs and the SNs, and I kind of highlighted how that you can check to see that they work, that you can sub in the letters, but I kind of didn't mention how they should be used, or why we use them, or why we have them. But like, let's say if I went back to this, and it will be the exact same for this one, but I will have to do an example because of how the nature of the thing, but we'll talk about it. But let's say here for the 3, 5, 7, 9, 11, I wanted to know what the 223rd number in that list is. I do not want to go all the way down to the 223rd number. So what I would do is I would go to the TN formula that I found, if you remember from here. Well, you guys probably have a better recollection of it. It's been a while for me. But I would take that guy, and what I would do is if I want to find the 223rd number, I would just sub in 223 everywhere I see the N. Now I wrote it in a weird way because I forgot the 2 initially. But basically I took the 2n plus 1, and instead of the N I replaced it with 223. When you put that in your calculator, you will get 447, I think. I might be doing maths wrong, but you get what I'm trying to do. So basically, the 223rd number in this list should be 447. Now, they might ask you to do that. They might say, what is the 46th number? What is 223rd? What is the 9,000th number? They might also say, when does the number 200, I won't use 223 again because that might confuse the issue. Let's say they say, when does the number 747? No, because that's kind of similar to that one. When does the number 129 show up in the list? When does it show up? Not what is the 129th number. When will, like how many more loops will I have to do until 129 is here, is the question. So like it'd be 1st, 2nd, 3rd, 4th, 5th, 39th number, 40th number, I don't know. So we're going to figure that out, and the way we would do that is you do it in reverse. We know that the formula 2n plus 1 should give us, what did I say, 129? Should give us 129 as an answer. So we put the formula equals to 129 because we know it is the answer for some n. And some nerds out there, some of you are going to be like, oh, just keep subbing in numbers till it works. Don't do that. So basically then you'd move the 1 across and it becomes a minus. 129 minus 1 is 128. And then divide both sides by 2 and you'd get 64. I'm kind of skipping a few of the algebra steps because what I'm going to plan on doing is maybe do another video just for all of that crap. This is more so the setting up of it. So much of the maths questions is the setting up is important. Those extra 3 lines at the bottom, that's just algebra. You actually don't get a huge amount of marks for those, but don't take that as the, oh great, now I don't have to do it. I'll just do the first ones. Graham said, try your hardest, but like, I swear to God, setting up is by far the better thing to do. You get the majority of the marks for the first line in both of those little bits I've just done there since we're coming back. But those are the 2 different variations where they'll either say, what is the 223rd number? And you sub it in. Or they say, when is the number 129? So in the examples I've done, I found the 223rd number in the list is 447. And I found out that 129 is the 64th number in the list. That's how that works. It's 2 different ways, forwards and backwards. Some people like to think of it. Don't just be on your toes and see which one. Try to be sure which one they're asking you. If you're not overly sure, obviously try one or the other. But like try. It is kind of important that you read the question properly to try and make sure that you know which one they're asking for and not just going to make a mistake. Also, I want to highlight I have been making a couple of mistakes today, not necessarily in this video, but just be prepared. If I have made a mistake, it is highly likely because there's been 2 or 3 today when I was doing maths with people IRL, and it was just I don't know, it's just weird. It's like my brain wasn't fully clicked in. Maybe I shouldn't be doing the video, but it's hard to find time and actual effort, you know. Now, in the same fashion, it can kind of work for the SN formula, where they might say, what do the first 14 numbers add up to? In which case, you would take your boy again. Hold on, the pen's weird. Take this guy again, because it's the SN formula this time, and you notice I did find this to be the SN formula. So you would take that guy, and let's say I wanted to know the first 14 numbers add up to. I would do S14, and everywhere I see N, I would replace it with 14 instead. And that will be 224, I think. It's not hugely important if I got that number wrong, but you can use your calculator. But it would tell you that the first 14 numbers in that list add up to 224. But let's say I wanted to find out when do the first... how many numbers do I have to add together before I get to 35, let's say. Yeah, 35 is in the list. 48 will be in the list. I'll use that one because it's bigger. I'm not trying to cop out by using small numbers. I just can't think that far ahead what number will actually work. 48 I think does work. So what I would do is I'd put the formula equals to 48. So I know how many of the numbers I'd have to add up to get 48. Now, if you're ever in a scenario like this one was handy because it was just, move the n's to one side, move the numbers to the other side, divide both sides by whatever numbers in front of the n, and you're done. You notice here we have an n squared, a 2n, and a 48. So that's an n squared, an n, and a number. Bring the n squared over, make it a minus. I forgot the n. That's an n. I know I said someone was bullying me about my n's earlier. Yep. Now, you'll notice that is a quadratic. We use the minus b formula or the brackets. Again, I'm not going to spend too much time on that because I'll probably do another video for that. But basically, the idea is you would end up with... what would that be? Maybe I should have tried doing this before. Yeah, no, I thought of it. Before doing it, I should have actually considered the numbers so I'm not frozen there trying to figure out what goes on. But basically, I'm skipping a few steps. I will do the actual video on that at some point. But the two answers you would get if you did the minus b formula there are 6 and minus 8. So that means I would either have to add the first 6 numbers together to make 48, or the first minus 8 numbers together to make 48, which does not make a lick of sense. So we ignore that guy and we do that one. And it doesn't make sense because n represents the number of numbers that we care about in this list. And you can't have minus 8 numbers in a list. That just doesn't make sense. The maths would tell us it does, because mathematically if you dive into a realm or dimension where minus numbers are workable in real life as opposed to just on paper, you know, then it would work. But like, you can't have minus 7 chickens, you know. So that's the two different variations you can have on this. Either sub in the thing for n, or what n will I have to sub in to get the thing. Okay. Sorry, people just text me. Yeah, so that's what it is. I was going to do it with the quadratic one, but we already ran into a quadratic version. That's what I was kind of expecting. So here, it would be the exact same thing. I won't do it out if that's okay, because it's the exact same thing. You either sub in the value for n and just get an answer, and that will tell you what that number is. It will tell you what the 223rd number is, tell you what the first 14 numbers added together is, and then there's the other variation where it says put it equal to. But if you do it up here, you'll just get a quadratic equals to a number, bring the number over, make it a minus, and you just get this scenario again where you just have to do the minus b formula. That's all. Okay, I think I'm satisfied with doing that stuff. This is the part where I'm going to do maybe an ordinary level question from the leaving cert. If you don't want to do junior cert, people I think can just dip out here if there were any here to begin with. Honors people, you might want to skip ahead, and what I'll do is, as I said, I'll put in like a little placeholder to kind of say, yo, snap back into this. But for honors, leaving cert, if you want to do an example of a question, I'll do one out here. And the idea is, and I'm just going to dive into it, I suppose, that a very common idea is that when they ask you to do shit like this, they'll just literally ask you to draw the next number in the pattern. Which seems a bit silly when you're like, you know, 18 and you have a job and you can vote and drive, and you go to leaving cert and like draw a picture based on the dots and the crosses, and you feel silly, but you just have to do it. You get marks for it, so let's not complain. And there's not really much I can help you with here for like teaching you how to recognize the pattern and how to draw it. You know, so just do it, I suppose. Having said that, I hope I don't get it wrong, because that would be embarrassing. But basically, the idea is just try out the next one, and the benefit of that is that we'll be able to make the sequence ourselves from it. Now, the actual maths, it says find a formula in n for the number of dots in the pattern n of the sequence Tn. I don't know if this is the best question to be doing, but it was the one that came up in 2021's Leaving Cert, I think, so it's just the most recent version that incorporates a lot in ordinary level, so I just thought it was kind of handy. Yeah, so find a formula in it. So, so for the dots, right? Now, you'll notice the dots, what we do is, we're going to make a sequence that represents the number of dots. In the first one, we do number 1. Or we do 1 just because there's simply a single dot in the first one. In the second one, we're going to do 2 because there is 2 dots, and then 3 because there's 3 dots, 4 because there's 4 dots. To find the formula, we need to know which Tn to use, so we're going to identify whether it's linear or quadratic, and you notice when you do the first layer, they're all the same. 1, 1, 1. That means this is linear. I clearly ran out of room. So it's linear, so immediately we know that when we go to our log tables, we can use... can I drag it down? Do I still have it here? It's bringing shit with it, but just bear with me for the moment. Basically, when we find out it's linear, we can definitely use the arithmetic or linear section, the first two. In ordinary Leaving Cert, you're never going to need this section. You're never going to use the second half. Do not use the second half. Only use the top section. Now it says find a formula in n for the number of dots that would be in pattern n. It even says Tn, but because it's saying the nth pattern, it is the Tn. Write down the goddamn formula. If I see any nerd not doing that, well, I'll just be very angry. There's not much I can do. But the idea is, again, A is the first number in that list, which is 1. And D is the common difference, which is also 1, rather weirdly. So here I'm just going to sub in. Now I know you're not supposed to write it outside the box anymore, but just due to the zoom I have on this to fit in as much as possible, I'm going to be going outside of it. It's fine. You guys will have plenty of room to write. Don't be annoying me. But what we would do is then we'd multiply in by the 1 into the bracket, this one now, just to avoid confusion. And we'd end up with n minus 1. And plus 1 and minus 1, they cancel. So you're just left with Tn is equal to n, which makes sense, because if you'll notice, what it's saying is the amount of dots in the nth sequence is n. So what it means is, in the 4th sequence, there are 4 dots. In the 3rd sequence, there are 3 dots. So whatever number is with the t will just be the number in the thing. Now, they don't ask it in the next question, so I can go into it. For example, if I want to know how many dots were in T7, everywhere I see n, I would put a 7, but you notice that just means the 7th one will have 7 dots. This was a very simple one. I think in a weird way they made it super simple to confuse you, to upset you, because you look at that and you're kind of like, well, that can't be it. It is. Find the total number of dots in the first 20 patterns of the sequence together is what is kind of insinuated here, because it doesn't say what is the number of dots in the 20th. They're saying what is the total number of dots in the 20 patterns. So we have to just do the SN formula this time. Now, this has less room, and I need, I think, more room for this, so let's just be prepared for shenanigans to occur. I'm trying to write smaller. I could zoom in, but like effort, you know what I mean? I kind of want to just rant about the junior cert again, the new junior cycle stuff, but I don't think you guys care. Now, A is the same and D is the same. They're both still 1. Now, here, there's 2 different ways of doing this, actually. I just want to point out, there is one way that I do it, and I just kind of want to highlight it, because I understand it might just be my own bias, and you might prefer to do it your own way, and I want to give you the option. But what I would do here is I would sub in 1 for A and 1 for D, multiply it all out, get a formula, and then sub in 20 for N, because they did specifically ask for the first 20, and that is what S20 is. The reason I would do that is because that way, if in a later question it asks us to find S30, we will already have the formula and we will just have to throw 30 in, rather than having to do the entire question out from scratch. However, some people prefer to do it that way, just from scratch. Because I have already done it in the other way above, when I was doing the last bits, where I found the formula and then subbed in, I will do it the other way here to show you the other way, and also because it will give me, I think it works out better for the amount of space I have. But what some people like to do is they will say, well, if that's the SN formula, then the S20, which is what they're asking us for, would be 20 over 2, 2 times 1, because A is 1, N is 20 minus 1, and then D is 1. And you will just throw that all into your calculator, and you will get 10 plus 22, 10 maybe. Again, I've been making mistakes today. It's fine though. You can throw it in your calculator. The idea is though that if you wanted to find out how many dots you'd need to make all 20 patterns together, you'd need 210 dots. If you counted all the dots in the first 20 patterns, you'd get 210 dots. It can be said different ways. Sometimes they'll say matchsticks and be like, how many matchsticks would you need to make the first 20? Sorry, I don't want it to go on so long though, so I'm gonna keep talking and hopefully just move faster. You can always pause. You can always put me in. I think you can put me in slow motion as well, which might be strange, but we'll see. The table shows the number of crosses in the first 2 patterns. I'm looking at IV now. Complete the table and hence find a formula for the number of crosses in the pattern N of the sequence. I don't like these types of questions, and I'll explain why in a second, but they constantly do it in ordinary level. Number of crosses, literally just count them. 1, 4, 9, 16, right? Now, they wanted you to kind of figure out, and this is the bit I don't like, they wanted you to be able to just understand the pattern. Now, what you could do is try at the 5th and 6th and recognize that it would be 25 and 36. But this is a very common list of numbers they use in ordinary level, so watch out for it, because all of these numbers are square numbers. You'll notice that now, you don't need to write this, I'm just going to highlight it to you. 1 is 1 squared, 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared, 36 is 6 squared. And they want you to kind of be able to see this, and I don't really agree with that, because that's not really a, sure, now that I've highlighted it you might see it, but it's very much like a did you notice, and it's your leave insert, I shouldn't do that. But basically the way it works is, if you want to find out what number goes in this box, you take the number above it in this layer and square it. That's what it is. And that's the English way of saying it. If I want to find out what number goes in the second box, I square the number in the box above it. However, the maths way of saying that would be, if the pattern is N, so pattern 1 was 1 squared, pattern 2 was 2 squared, pattern 3 was 3 squared, so pattern N would be N squared. And they want you, because look how much space they gave you. They did this, I remember them doing this in like 2016 or some shit. I remember this ages ago, happened in 2017. And they left like no room. And they do it on purpose. I don't know why. I do not know why. But they definitely will mention it from every now and again, and just be on your toes that if that list of numbers comes up, it is N squared, because it is just whatever number is above it squared. Whatever number in the pattern it is squared. You'll notice in part V where it says find the number of crosses in pattern 12. If we follow the pattern of patterns, that wasn't on purpose. But basically, for if we wanted to find out how many crosses there were, we squared whatever pattern it was. So with pattern 12, it's 12 squared, which is 144. Find the number of shapes. I hope that's okay. That's just like put in 12 into this formula or follow the pattern. It's up to you. Find the number of shapes, dots, and crosses in pattern 10 of the sequence. So what I'm going to do is we have to find them separately. So for dots, do you remember we said all the way over here that Tn formula for dots was just N. So if I want to find T10, yep, that's fine. If I want to find T10, I would just sub 10 in everywhere I see N, and it would mean that there are 10 dots in the 10th one. If I want to find out how many crosses there are in the 10th one, I'd follow this pattern up here and just say it's 10 squared, which is 100. Now if they want to combine the number of shapes, it's just 100 plus 10, which is 110. Now I do want to point out that this it might seem slightly easier when I'm just kind of doing it, and I think that's the problem with a lot of the questions, that they're not, when I do them, you guys are like, yeah, I can see it when you're doing it, but obviously when you're on your own, it's a lot harder. So don't get weirdly disheartened when I'm like, I've done a lot more maths than you guys. You're not necessarily supposed to do it that fast or find it that easy, or don't stress. It's fine. You'll be fine. I will do part B though, and part B is kind of the juicier part, the kind of the more hard part, and that's why I think it's kind of handy to do. I will point out, at no point in the other questions that we just did there did it do that reverse that I said, where it might say, oh, in what sequence is there 121 dots? No, crosses. Well, in what sequence is there 121 crosses? And you would go back and say, well, it's the reverse, so therefore n squared equals 121. And square both sides, get rid of the squared, or square root both sides, get rid of the squared. Just maybe I shouldn't even highlight it, it might confuse the issue, but they didn't do that, and I just find it kind of off-putting that I did it and then went into a question immediately that they didn't do it in. So just to warn you, this one is like completely different, because you notice it's a new pattern. The first two patterns of a sequence of patterns of crosses are shown below. There's a lot of words. So pattern 1 has an X in it, pattern 2 has 3 X's in it, or cross, or whatever they're going to do. Crosses, yeah. The number of crosses in pattern N is Tn. We know that. That's just the name that we give it. The general term describing Tn can be written in this form. So that means, you notice there's an n squared, a b, or an n squared, an n, and a number on its own. Now it is a c, and you're like, well, Graham, c isn't a number. But you have to remember that what that means is there's a number there. They're just not telling us what it is. So they put a letter in to kind of hide it. So our numbers though, if we were to try and make the list ourselves, we would say 1, 3, because that's how many crosses are in the first and in the second. We don't know though what is going on. However, they've highlighted to us that it is a quadratic sequence, because it is in the form of a quadratic. There's an n squared, an n, and a number. So I would have said to you earlier that to get a, it's always half of the second difference, which is fine, but they haven't. They didn't make you do that, and they very often in ordinary won't always ask you to do that. They will give you the first bit. It's n squared over 2. Don't worry about it. It just means shenanigans went on. And the second difference is 1, and they halved it and they got a half. Don't worry about it. Honest to God, it's fine. Very often they'll just give you what A is here, and you don't have to worry about it. The B and the C is what they want you to worry about, which is fine, because we're class at that. We'll be fine. Use substitution for n to write T1 and T2 in terms of B, C, and a number. So the wording might be scary to people who aren't maths people, but it's basically asking us to do exactly what we did earlier when I found T1 and T2, and I got two equations and did the simultaneous. And you notice down here when it says hence or otherwise find the value of B and C, that's where I'm going to do this simultaneous. So here T1 should be the first number in the sequence, right? So it should be 1. We should be able to just say T1 is equal to 1, and we can say that. However, we also wanted to work that when I put 1 everywhere I see n in the Tn formula, like instead of writing Tn, we're writing T1. So the n is being replaced with 1s everywhere. So that's what I'm going to do here. I'm just going to write it. Now, again, for space reasons, I'm going to just make it might look a bit jank, to be honest with you. But everywhere I see an n, I'm going to put a 1. And I want it to work in a way that it gives me the first number, so it's equal to 1. Then I'm going to multiply it out ever so slightly. Yeah, it does look a bit messy. It does look a bit messy. Let me think. Yeah. I think you're okay for doing this. I don't think they actually wanted you to necessarily put in the equals 1, because it says write T1 and 1 is the first term, so 1. Again, don't worry about that. That's just me kind of thinking. I think they wanted you just kind of to do this, but I don't think they should have done that in a weird way. I know that sounds a bit annoying, that I'm just kind of being a bit too like, well, this isn't the way I would have done it. What I mean is they've tried to help you by putting these in, but I think it's just kind of confused it ever so slightly, where it looks different to how you would normally do it. And then down here they want you to put the thing in, but down here, yeah, I'm not. So I think they want you to just do it like this, and just this is your answer. However, in my mind, what I would do is I would put it equal to the 1, and then bring the half over, make it a minus, and do 1 minus a half. That's what I told you to do earlier. And then change it to b plus c is equal to 1 over 2, or a half. Because it was equal to 1, and we brought the half over, made it a minus. So it became this crap. So we got b plus c is equal to a half. I'm kind of torn, because I think what they wanted you to do was just do this. Because you notice that was right t1, which is what this is. So what I did was I replaced n with 1 and just wrote this formula out. And then I multiplied out the crap and I got this. That's not how I think they should have done it. That's not how, yeah, it's not the most, they've literally just gone out of their way to try and make it easier, but made it harder, I think, and I just don't really agree with it. But we'll go with it for now, It just means we're going to have to do more work in this part, but we'll go with it for now. If it was t2, it just means sub 2 in everywhere you see a squared, or see an n, sorry, Jesus. So you get like this, and then you'd get this, and then you'd get this. And then when you do this out, you get 2 plus 2b plus c. That is for t2, right? That, you know, I know it's, again, space is fucked up as well. But basically, t2 is this guy, and t1, it was initially this guy, but now it's this guy. You know what I mean? That's kind of how I'm working with this. Space-wise, it's just a bit weird. Now, so we're going to have to remember our first number in the list was 1, the second number in the list was 3. I know this seems a bit weird. They have thrown me, myself, with the wording of this question. It's not done in a way that I think helps you guys. But maybe it is. Maybe I'm just being a miserable git. I don't know. But basically, we know from above, I'll try to keep it color-coded so you can kind of see what's what. We know from above this statement is true. We also know that this statement is true. But T1 is the first number in the list, and if you remember, T1 is 1. It's the first number in the list. You can go back, I just don't have to scroll back up if that's okay. But there was 1 cross in the first thing, in the first diagram, so therefore T1 is 1. There were 3 crosses in the second one, so for T2, I'm going to do similar. I'm going to put in 3 though. Hopefully you remember, this question is jarring, so I'm just not going to engage it too hard, I guess. But basically the idea is T1 is the first term, which in our sequence, in our list was 1, because there was 1 cross in the first one, and the second one is 3, because there was 3 crosses in the second. Did I say that right? Did I say that completely wrong? There was 1 cross in the first one, so T1 is 1. There were 3 crosses in the second one, so T2 is 3. You might want to listen to that a couple of times for it to make sense, because I don't know. I'm losing it. But then what you want to do is bring the half over, make it a minus, so you end up with 1 minus a half is equal to b plus c, and then you end up with a half is equal to b plus c. Then over here you'd bring a 2 across, make it a minus, and you'd end up with 3 minus 2 is equal to 2b plus c. 3 minus 2 is 1, so you'd end up with 1 is equal to 2b plus c. And then again, this is where we get into the bit earlier where we have to do simultaneous equations. But what you can do is just multiply one of the whole lines by minus 1. I'm going to do this one. It doesn't matter, because you notice they both, as I predicted earlier, will always have a plus c at the end, right? That'll always happen. So all you have to do in these simultaneous, not every simultaneous equation, it's just the ones in the sequences and series section, multiply by minus 1. I'm going to multiply this guy by minus 1, so it's going to be minus a half equals minus b minus c. And under it, I'm just going to write out this guy, which is 1 equals 2b plus c. Draw a line. 1 minus a half and plus 1, you could put it in the calculator if you don't like it, but it is a half. 2b minus b is b, and then the c's cancel, and you're left with, oh, b is a half. Then, once you find one letter, you sub it in to one of the 2 original equations. I'll just pick this one because it's here. So we had 1 equals 2b plus c. But everywhere we see B, we're going to have a half instead, which is 1. And bring that over makes it minus, and we'll have 0 is equal to C. Now that is what they wanted you to get. They said find the value of B and C. That's what we did. Sometimes they'd say rewrite out the original guy and you will lose marks if you don't actually. Now not here, but you will lose marks normally, or not normally, in the other way of writing it, if you don't go back and then write out the guy, but instead of B, put in your half that you found. So you could say like this, and then instead of C, put in your plus 0, which you can do, or because it's 0, you can just leave out entirely, and that is the answer. Okay, I didn't like that bit. I think you guys can see it through me slightly, and I think it's just me being stubborn that I wanted to do it my own way anyway, because in my mind my way is better, but that could just be my own stubbornness. Really, you should just listen to, obviously a group of people that, I'm going to get carried away at times and be like, that's stupid, let's do it my way. And obviously in my head, that's because that's correct, but sometimes it might just be my own, I don't know what another word, bullheadedness, is that a word for stubbornness? But you know what I'm saying, that I don't know. It just seems so weird the way they did it. And I feel like it's like they tried to help you, but it didn't. It just backfired almost and just made it look not how you're used to seeing it. Maybe that's what they wanted. Maybe they wanted it to not look how you're used to seeing it, but that's not helpful either then. I don't really understand it. Maybe I'm missing a bit. Who knows? I could, I'm just a guy. Now, I think at this point, I will put in the card. I think ordinary people can dip out here, unless I've had a thought, since, like, after I do this, where I kind of go, oh crap, I never did, blah, and I have to frantically run back and do it. And then I'll awkwardly have cut in another video before this. Hopefully. Can I do that? I'll figure it out. I don't know. But yeah, hopefully, I think at this point, ordinary level students can go now as well. So all that should be watching this next bit is honor level leaving cert students, because nobody else needs this bit. I will put in the place card thing, and hopefully I've covered everything that I don't have to do it. I guess I'll leave a space now to have the thing. All right. Welcome back, maybe, or thanks for sticking around also. I don't know. It depends on what you did. Hopefully I put in the card right. I was having all sorts of kind of, oh, do I have to make a break in the thing? Maybe I have to make a break in the video. I'll have to figure that out. But just while I'm on a roll, I'm just going to keep going, I guess. And hopefully I don't, in the sprawl that this video has become, because I didn't really plan ahead of what I was going to do. I just kind of sat down, and we're just going to go through this shit as it unfolds, basically. This video is going to look real long, and I know that's going to be an issue, but like as we saw, a lot of it is, you can cut out a lot of bits and a lot of pieces, so don't give out. Basically, for honor level leaving cert students, the same thing kind of applies with the TN and the SN formula for geometric series, or is it still working? Yeah, sorry, I think my internet dropped for a second, and the whiteboard doesn't work without the internet, but I think the recording is still fine, maybe. But the idea is that the TN and the SN formula work exactly the same for exponential or geometric. However, the difference is, instead of finding D, which is the common differences in how much you're adding on each time, you have to find out what OR is, which is the common ratio, which is how much you're multiplying by each time. And the way you do that is, and this is a common idea that they always use, so in an arithmetic sequence, you would do T2, let's say, minus T1 to find out what D is, because in arithmetic sequences we were adding on adding on each time. So if they ask you for D, you obviously would do the second one, take away the first one to kind of go backwards. It doesn't have to necessarily be that. It could be T3 minus T2, you know what I mean? As long as you're always multiplying or doing a number, take away the one that came before it. And that's T of n minus 1. It is not T of n minus 1. Those are two separate things. But the idea is, as long as whatever Tn is, let's say n is 17, then this would be 16. So T17 minus T16 should also give you D, right? They should all work out the same. In in a geometric sequence, what it should be is T2 divided by T1 gives you or. And again, that could also be T3 over T2. That's a 3 over a 2, alright. T4 over T3. Or again, like I was saying, it could be Tn over Tn minus 1. Basically, instead of doing bigger number minus the one that came before it, you do bigger number divided by the number that came before it. It mightn't even be bigger in some cases, and we'll see that in a second. But that is a common question. They will very often do that in algebra, where they say like the first 3 terms of a sequence are like x 5x plus. There was one example I'm kind of copying here, but I'm getting it wrong, so it's not going to work out fantastically. So they said it was like your first number is x, your second number is 5x plus 8. So then it would be oh god, I've made that very strange. I wouldn't look. Don't worry about it. Something like x squared minus 9 or some shit. I don't know. But the idea was that what you had to do was you had to say, well, if I want to know what they multiplied the first number by to get the second number, I would do the second number divided by the first guy. Or what you could do is you could do the third guy divided by the second guy. And they should give you the same answer, so therefore they should be equal. And wow, we now have immediately out of the buttfuck nowhere, we have an equation with x's and numbers all over the place. You do your multiplying both sides, do your cross multiplying if you're a little weirdo who wants to annoy me. But basically you can turn that into actual algebra. I think it turns into a cubic, and then in the leave insert it asks you to do the factor theorem. But again, I will do that in a different question, so I'm not, or in a different video, so I'm not too pushed about that. But hopefully that's okay. That's a common idea that they'll do. They'll give you the stuff in algebra, you just do the exact same. What would I do in numbers? Oh, I'd do that. I'll do the exact same. Now, you'll notice that here, if I did, like, for example, 81 divided by 27, you would get 3, and that should work for no matter what number you do, divided by the number that comes before it. Should be 3. You'll notice, weirdly enough, in these, it works out for the loops as well, or all geometric series of factor 3, of ratio 3 as well. I find that amusing. But the Tn formula for geometric series is A or R, if you're one of those people, to the power of n minus 1. A is the first number in the list, which is 3. Now, annoyingly, or is 3 here as well. Sorry, I didn't think ahead, alright. And it'd be n minus 1. Now, normally, that would just be it. That's the step that you stop. In green, I'm going to do this bit because I did make it a weird one, but it's kind of good. It kind of can prove useful. Because if you think about it, that's 3 to the power of 1, multiplied by 3 to the power of n minus 1. And you can use your indices rules to make that 3 to the power of 1 plus n minus 1, which is 3 to the power of n. Now that's a weird edge case that I'm doing. That's not the way it will always work. The blue bit is the safer way. I wouldn't worry too much about that. I'm rubbing it away. Yeah. That's more, I'll do it again. I know I keep saying I'm going to do videos and I never do, but it's because you guys drain the life out of me. And I don't have the will to do any of this shit. But that's the Tn formula then for that. So if I put in if I put in 5, for example, I would end up with 3 multiplied by 3 to the power of 5 minus 1. And if you put that in your calculator, trust me, it is 243. Wow. Well, don't trust me. Put it in your calculator then. But that's cool. Now, Sn works the exact same way. We would do Sn is equal to A1 minus or to the power of n all over 1 minus or. This is the most important fucking thing here because it is used a lot in sequences and series. They also use S infinity a lot, but the difference is Sn is also used for like the entirety of leaving cert honor level maths. So, or financial maths, Jesus. So, if you want to try the financial maths question in leaving cert honors, you need the Sn formula. That's why I think it's so important. That's why I'm doing this video, because I know for a fact that just people aren't doing it. That's just crazy to me. But if you just sub in the things again, I'm sorry that I picked an A and an or that are the same number. It doesn't look right when we do it, but that is what you would do. And what is it? Just, if we were to just tidy it up ever so slightly, you can only tidy up the bit on the bottom, don't forget, because you'll notice that 3 to the power of n would have to be done first. And we can't do that because we don't know what n is. So we can't do 1 minus 3, we can't do 1 multiplied by 3, we can't multiply the 3 into the bracket, we can't do anything because we don't know what the power of n is. And according to BIMDAS, you have to do what's inside the brackets first, granted, but we can't do what's inside of the brackets. And we can't do indices, or we can't do the multiplication because indices comes before that. It's good fun. I know you're all loving it. You're welcome. Now the S infinity is the quirkiest one here. And you notice it's kind of like a simple enough looking formula, but the idea is that this will tell us what the first, in the same way Sn works, that it will tell us what the first n numbers add up to. If you haven't watched the earlier bits, I've mentioned all that shit. That Tn is the nth term, Sn is what the first n numbers add up to. Should have been here, you missed out, your fault. But S infinity will tell us what the first infinity numbers add up to, which I know to some people that's kind of like, that doesn't make sense. But it really just means that it adds up a never-ending list of numbers, just go on forever. However, there is a thing to it that kind of limits it. A limitation, I guess, but I can't do this formula for my list of numbers because or in my list of numbers was 3. And the only way you can use S infinity is if the or you use is in between 1 and minus 1. And that's what they've kind of tried to highlight here. Now, they've written it in a way that I can appreciate, but you guys might not like. It's saying the absolute value of or has to be less than 1. That means on a number line, the or cannot be more than 1 away from 0. So if, let's say this was like 1, 2, this is minus 1, this is minus 2. Basically what you have to kind of realize is it just means that or has to be in between minus 1 and 1. It has to be a number on the number line in between these two. Or else S infinity won't work because it'll just be infinity. Because the maths won't work out to be infinity, but okay, let me rephrase this. The formula won't work. However, the maths would just be infinity. The formula here would just tell you that it's 3 over 1 minus 3, which is minus 3 over 2. That's not correct. That is not true. If you were to add these numbers up forever, it would be infinity, so you can't use it here. Again, can't stress that enough. Or has to be in between minus 1 and 1 for you to be able to use S infinity. That's the logic here. Okay. Is there anything else I want to really say about this? If you were here for the earlier bits, you would have seen all the nuanced bits to it, where it's like, oh, if they say when is, or what is the sixth number, you'd sub in 6 for Tn. If they say what did the first 17 numbers add up to, you'd sub in 17 for Sn, or for the n in Sn. If they said to you, when will, like let's say for the patterns you need a certain amount of matchsticks or something to make it. In the first pattern you need 3, in the second one you need 9, in the third one you need 27. They might say, how many of the patterns can I make up if I have 1,000 matchsticks? And what you would do is you take your Sn formula and equate it to 1,000 and then do algebra to find out what n would have to be in that scenario. It can get a bit messy when they do that, but they will more so lean towards some sort of S infinity type nonsense. Now, okay, so what I'm thinking of doing is I'm going to do maybe an actual leaving cert question, but before that, there is one more thing I want to highlight. I think one more. Before we actually get into the nitty gritty of actually doing maths, there's one more bit of theory to talk about. That they will sometimes just be dicks and give you just some random ass formula that they've just made up, and it will show up like this, and people just do not like it. They might say like, oh, A1 is equal to 0, A2 is equal to 1. And then they won't tell you what A3 and A4 and A5 is, but they will give you this formula. For any AN, what you do is you do AN minus 1 plus A of n, or AN minus 2. Now what that means is that if you wanted to find A3, for example, what you would do is everywhere you see an n, and you'd, like, because you've kind of labeled n to be 3, so you would do that here. and you would get this, and then you would say, oh, that means A3 is A2 plus A1. Just doing the maths. So what you would say is A3 then is 1 plus 0, which is 1. So then I can go over here and I can say, well, that means A3 is equal to 1. But then what you would do is, well, for A4 then, it would be A4 minus 1, just again subbing 4 into everywhere I see n here and here. And so it'll be like this. And that is A3. Maybe I should have done this slightly bigger writing, but hopefully you can understand that in all this green writing I've done on the left, the A is the plus and the equals are the only normal sized things. The other numbers, the 3s and the 1s and the 2s, are all being, well, apart from in this line, obviously those are numbers, don't be mean. Well, like in these lines, the 3s and the 1s and the 2s are small, right? We call them subscripts. It's kind of like the opposite. You know the way you might have A squared? A2 is just, that's superscript, this is subscript. It just is kind of like a naming idea that we have that I would not worry about it. They'll do it on purpose because they know you're not comfortable with it. But the idea is A3 is 1, A2 is 1, that is 2. So then I can go back up here and say, oh, well, therefore A4 is 2. And you would just, they might say something like, find the first 8 numbers in this pattern. They might say, what do you think of this? Or what's, you know, your star sign? How do you do this question? They'll ask you some nonsense about it. But basically, I will tell you, this is kind of the maths way of saying that any number you want in the list, like this, is made up of the 2 previous numbers in the list added together. Because you notice that's just what we've been doing. Because for the third one I added 0 and 1 and I got 1. For the fourth one I added 1 and 1 and I got 2. And I can tell you for A5 we'd add 1 and 2 and I'd get 3. Because this is the Fibonacci sequence, which is every number is the sum of the 2 previous numbers in the list, assuming you start with 0 and 1, I think, or maybe 1 and 1. It depends on what people have decided. But that's how they will do it. They won't do it like that basic. That is, in the maths world, the Fibonacci sequence is considered famous enough that we mistakenly lead ourselves to believe that normal people will have seen it before, so they won't put it in the actual leaving cert. They do weird stuff, but we'll see that when I do the question now in a second. I think that's all I kind of want to say about like the nature of the sequences and series in leaving cert. So I'm gonna just I'm just gonna hold on. I'm on actually a different page. I don't think you can see it. I hope you guys can see it. Not because there's anything sketch on it, but just because it means that I understand how to work the OBS systems basically. But what I did was I went to another tab and I found this, and you notice it's similar, but instead of using A1 and A2, they used U1 and U2. Same shit. They're just trying to annoy you. Don't let the terrorists win, right? So what we're going to do is we're going to have a quick look at this, and I'll just run through it. I think I've covered kind of like all the basics of it, all like the kind of the tools, if you get me, of it. Now we're going to talk about how to use them. So if you don't want to do that bit, that's fine. You can bounce. I'm hopefully, look, the video is going to be quite long. I know, I get it. I just enjoy doing the maths, all right? But also, I think these are all just screwed, and you're not going to do well. So I'm trying to give you as much as possible. But you know, if you prefer to mindlessly just look at TikTok with your mouth hanging open, go for it. But a sequence U1, U2, U3, etc., etc., is defined as follows. For n being natural numbers, you can almost ignore that bit, but it just means that the numbers in the place of n have to be positive whole numbers. Any whole number above 0. And they're saying U1 is 2, so the first number in the list is 2. The second number in the list is 64. Un plus 1 is equal to this. So that is the formula for what to find next. Now this one only asks for U3. It doesn't ask for any extras because it wants it specifically in this form, and because they're asking for it in a weird form, they were kind of like, we can't do it to the kids where we would make it where we have to do again and again and again, because it is kind of gross looking and they want the answer weird, so they're not going to make you do like 4, 5, and 6. But if we want U3, that means we need this number to be a 3. So they weren't as nice as I was, where I said this was just UN and kind of work out from there. They said U3. If we want this to be U3, we want that there. you kind of have to think to yourself, what number would I have to put in for n to make this a 3 in total? And it would have to be a 2, right? Because then it would have to be a 2 plus 1 would become a u3. But that means everywhere I see an n, I have to put a 2 for the pattern to make sense for what they've said. And you'll notice that what happens is, I'll move that down, that's too much, that's too close. What we'd say is u3 is equal to u2 over u1. Now I know the writing might seem small, I get that. I'm hoping that you just kind of understand what's going on, that what we've done is we've said if we want to have u3 be on the left, as in the formula on the right will dictate to us what u3 is, we'd have to sub in a 2 everywhere we see an n, and that's what I did. Any relevant maths that was needed I did, because now we have u3. Maybe I'm just tiring, I don't know, I've been doing this for a couple of hours now, so we'll see. And that's on top of the other maths before you're all like, oh, I've done longer than 2. Shut up. U2 is 64. Just from up here, U1 is 2. Now, some nerds immediately slam that into your calculator, and what will it give you? Like 4 root 2 or something. And people just think they're gas when they do it. They're like, oh, I'm amazing, I'm super. But they wanted you to write it in the form of 2 to the power of p. Even if you did this, you'd still get like 7 out of 10. Now, don't do that as in like, oh, well, then I'm not going to bottom you whole. If you want to do it as 2 to the power of p, what you can do, and you can do it weirdly either this or this, you're going to try to turn them into so that every number available is a 2, or if not a 2 to the power of something. So if we were to do it for, I'll do it for this one because this is the way most people would do it. They wouldn't, or this is the way that I think most mathematicians would do it. They wouldn't think to put it in the calculator and change this. What we would do is we'd say, well, first off, if you remember your log or indices rules, is what I should say, indices rules, square root is the same as the power of a half. So really, instead of a fraction inside of a square root, we can say fractions to the power of a half. 2 is 2 to the power of 1 on the bottom, because 2 is just the same as 2 to the power of 1. 64 is 2 to the power of 8. No, 2 to the power of 6. Yeah, 2 to the power of 6, I think. 2 to the power of 6 would be 4 by 4 by 4, which is 16 by 4, which is, yeah. So, basically, all of this just becomes all of this if you change it all to, if you translate it all into indices, and then you use your indices rules. If in indices you have two things being divided that are the same base but have powers on it, what you can do is you can change it to minusing. So you change that to 2 to the power of 6 minus 1 to the power of a half. Alexa, lights on. Then, Alexa, lights full.
Okay.
Then, 6 minus 1 is 5, so you'd have 2 to the power of 5 to the power of a half. And then if you have a situation like this, it tells you in the log tables what you can do is if you have a power inside and outside the brackets like that, you can multiply them. So the answer is 2 to the power of 5 over 2, which is fine because it says the p can be any number. It was the n here had to be a whole number. So 5 over 2 is fine, and that is the answer that they wanted. I will just real quick show you that over here what you could have done then is change the 4 into 2 squared, change the 2 in the square root to 2 to the power of a half, and then if you're multiplying these two together, what you can do is change it to where you're adding their powers, and put that in your calculator because these are all dense and can't do that in your head, and then you get 5 over 2 as well. Huzzah! That's the question. Again, the red and the blue bit is kind of algebra that's nothing to do with sequences and series, so it's kind of a bit sketchy, but that's what they want you to do. Anything else I wanted to do, because I am just considering just doing an entire long question. Yeah, hold on, I'm just going to show you this real quick as well. I am again in another tab, but you remember when I said that they sometimes will say here are the first 3 terms in terms of algebra, and you'll notice that what they've done here is this is like 2021 or something, one of the leave inserts. This is like the part B or part whatever the other one I just did. So it says the first 3 terms in an arithmetic sequence. So that means a number has been added to the same number has been added to, this, to get from 1 to 2 and 2 to 3. So like they added a number to get from here to here, and then they added a number to get from here to here. So that means that to get that number, what we could do is do the second one to minus the first one, or we could do the third one minus the second one, because they should both give us the same thing, and because they give us the same thing, we can say they're equal to each other. And then what we would do is, what way do you want to do? Because it goes into something that's not sequences and series, but that's kind of the build up. That's the sequences and series. They say letting y be equal to e to the power of k. There are a couple of ways of doing this, but the way I would think to do it is, if you have a minus power, you can slap it underneath the fraction and change it to a positive power. That's what I'm going to do. I'm not going to... sure, I'm almost there, basically. But everywhere you see the e to the power of k, then you would replace it with the y. And you would get your boy here. Multiply everything by y. To get rid of the fraction. You get this. And then bring everything to one side so that you're golden. And you'll notice that that does in fact give you what they asked for over here when you add the two 13s together. Well, minus the two 13s together, am I right? But yeah. So that's kind of like an example of what I was warning you about. Again, it delves very quickly. There's a part B or part 2 to it that has nothing to do with sequences and series, but it very quickly devolves into, you could argue, into sequences and series, or away from sequences and series like that. I'm just having a quick look. There was a long question in here that I thought was also relevant, so I'm just going to nab that. Oh, no, I didn't think it was relevant. That's just a blatant lie. They did do a bit in that year where it was about, I know you can't see it and I'm sorry, but I set it up like that so you wouldn't be seeing all the background noise that I'm doing, and I was afraid I was going to have it was going to be looking at the wrong tab, so I had to make sure it was. But the idea was that in that question, if you're looking at 2020, it's 2022, sorry, not 2021. If you're looking at 2022, there was a question about the amount of drug in a bloodstream, and it kind of was a geometric series because, well, maybe it's useful then, but the idea was that the amount of blood, or the amount of drug in your bloodstream decreased by 15% each day or something, I think they said. Yeah. So what that means is that each day you can multiply by 0.85 to find out how much is left. So they were basically saying, like, on day 14, how many things, and you would say, well, you're multiplying by 0.85, it's a geometric series, so you put you put the 0.85 as or. A is how much she starts with. I haven't seen it in the question, and you just do all that shit and you work it all out, and you have good fun doing it. But I will probably do 2021 instead, I think it is. And now you don't have to stay for this bit, obviously, because I think I've covered the entirety of it. If you're worried about it, then you can hang around for what I'm about to do here with the fucking grandfather clock. But I think I've covered everything. I'm always afraid to say that in case I haven't, and I'm afraid you guys are going to go off frolicking into a field thinking that you're fine and you have the entire thing covered, and I have just missed something and it's on me. But grandfather clock, none of you know what a clock looks like anymore because we live in the future, but the tip of the pendulum, which is okay, I was messing, but I genuinely, pendulum is this boy down here, alright? Hopefully the arrow kind of has signified that to you. Of a grandfather clock swings initially through an arc length of 45 centimeters, as in the length around this curve. I know I haven't made it look too much like a curve, but the length around this curve is 45 centimeters. On each successive swing, the length of the arc is 90% of the previous length, which is what they've kind of signified here, that when it swings back, it is 90%, and the maths way, that is completely not an arc, but the maths way would be 45 multiplied by 0.9 to figure that out. 0.9 is also 9 over 10, so if you want to put it as a fraction, you can do that. I think your calculators will work putting, if I remember correctly, if you put in 0.9, right, it will work. Your calculator will tell you what the decimal is every time you multiply by 0.9 because it's going to be 90%. So you multiply by 0.9 to find out what 90% of that number is. But they've done it in a way that here it will work, it'll give you a fraction, and here it'll work because it'll give you a fraction. But here, because the calculator is kind of a bit weird, it doesn't give it to you as a fraction for some reason. If I think, I have that in my head, I could be wrong. But it just gives it to you as a decimal, which is fine, I think. I think it's okay. But you can also just do it as 9 over 10 each time. So if I multiply 45 by 9 over 10, what does it work out to be? 405 over 10, which would be 81 over 5, I think. And then you multiply that by 9 over 10 and you get 729 over 50. Yeah, no, I've clearly made an error somewhere. Where's the calculator? I don't have one. No, I do. I just have to reach like a pleb. Okay. Crisis averted. 45 multiplied by 0.9 is... Oh, yeah. This calculator's balls. Okay, hang on. I have to reach for another calculator. Okay. Sorry for wasting your time there, bud. 45 by 9 over 10 is 81 over 2. Oh, yeah. Jesus. Can't believe I recorded like one of the worst maths errors in history. 81 over 2, that makes more sense. You multiply that by 9 over 10, you would perfectly get 729 over 20. I agree with them on that. Then what you would do is you'd say 729 over 20 multiplied by 0.9 or 9 over 10, whatever floats your boat. And by 9 over 10. Now that is 6561 over 200. Now I'm just curious, if you do by 9 over 10, yeah, it goes straight to a decimal, and no matter how many times you press the SD, it does not make it a fraction. What you could do is in your not in your head, but like multiply by 9 over 10 yourself, because if you're multiplying two fractions together, you multiply the top by the top, the bottom by the bottom. If you multiply the top by 9, you get 9. 4. 50. 9 by 6 is 54. You carry the 5, so it's 59 over 2,000, I think. I could be slightly wrong on that. You can just put in the decimal. Don't be a hero like me. All right. I think it is right, but you can put in the decimal. I just thought it was weird. I thought it might have thrown people in the exam where they're kind of like, oh, I must be doing something wrong if it's not coming up. They do it on purpose. It's just that the number was kind of like, here, to hell with it. We're giving them the decimal. It's too much nonsense going on. But that's what's going on there. Now, you'll notice I told you what Tn was, but if you just follow the idea of Tn is equal to, you don't have to do this. This is why I'm doing it out on the side. If you follow the idea of Tn is equal to a or to the power minus n or a or to the power of n minus 1. A is the first number, which is 45. Or is what you multiply by each time, which is 9 over 10, or 0.9. And then n minus 1 is just n minus 1. And you notice that's what they got. That's where they got it from. Not that you need to know that. No, you do need to know it. But what I mean is it's not in the question. I just thought it was kind of nice for you to know. Find the arc length of swing 25. Literally just means find T25. So everywhere you see n, put in 25. If this comes up in a leaving cert honor level, these two things again, and people get it wrong, look, I don't know, I'm full of empty threats. Just leave me alone, alright? I'm trying my best here to do all this and not have you be super bored. Trying to get it done as quick as possible. And you'd get 3 points. Now it's set to correct to one decimal place. It'd be 3.6, I think, when you put that in the calculator. Yeah, that's what it's looking like. Yeah, which kind of makes sense, I suppose, because it's getting smaller each time. Sick one. Now, you're going to have to bear with me for a second while I go and get the other one. The next parts. This is just kind of like how the leaving cert sequences and series questions go. I will go into more into the... I have stated, I think, already that it goes into financial maths, and we will do that in... I will maybe make a video on financial maths, and hopefully that will just be completely different. Because as far as I'm aware, the 6 years and 20... This is 2023 I'm making this. I don't know. God knows when you're watching this. But the teachers are kind of leaving out financial maths, or they're... Which, you know, obviously just time constraints. I get that. But I just think it's mad because it seems to be one that people like with money. I don't know. Find the total distance traveled. Total distance traveled by the tip of the pendulum when it has completed swing 40. Total means add all of them together. I'm not going to do that because I'm not a pleb. So what I'm going to do is I'm going to do S40 because it will add the first 40 swings for me. Now A is 45. The other thing you want to watch out, you see the way it says in centimeters? That's good because the thing is in centimeters. If they had said in meters, they can shadily do that. And then people immediately do the maths and then try to change the answer into meters when they recognize, or if they recognize it at all. But what you have to actually do is change that into 0.45 meters before you start any maths. If it had said meters, it does not. It says centimeters. Give your answers in centimeters. They're giving us the info in centimeters. we're fine. But if they had said that, you want to watch out for it. You want to make sure all the units are the same going in as what they should be coming out, and that they're all the same as each other. You can't put centimeters and meters together into the same formula. It's just nonsense to try to do that. I'm using the wrong goddamn formula, and none of you's warned me. I do apologize. I was using the SN formula for arithmetic. For geometric, it's A first. So what was A? 45. Then it's a bracket. It's 1 minus or. I do apologize, but like how and ever. AN should be to the power of 40 inside. Now it's important that people mess that up all the time. The N in that part of the formula is on the or, not the bracket. It's nothing to do with this one. It is just, or the minus even. It is the 0.9 is to the power of 40. That is it. And you will put that into your calculator. And I think first step would be like this. But you would put it all, now for me, not for you, don't worry about this. You will put it all in your calculator, and it says correct nearest whole number, so you literally just type it in. If I make a mistake on this, I'm always curious, because you guys are just going to be sitting there and obviously be like, oh shit, I don't know if he's right or if I've made a mistake. You know, if I'm floating around, I'm sure you can just message me and be like, yo, what is this? I'm curious to see, because now it says correct nearest whole number. That is just 443. A few videos I did, I was surprised with how well you guys received them. So not that like they're fantastic or you know, cover everything or are super educational, but I'm surprised you guys were okay with them. So I was which surprised by it, but it made it easier to do the next ones. So I guess it's all working out. But if you are doing these and you do see something that you think is an issue, feel free to message me. I'm sure if it's close enough to the leave insert, I will be frantically already like in your ear anyway. But swing P is the first swing which has an arc length of less than 2 centimeters. What is the value of P? So basically, how far, so like here's 1, here's 2, how far down that list of diagrams would we have to go for this arc down here to be 2 or smaller? So what we do is, if you remember, that's the TN they're looking for, not the SN. They're not asking for them all to add up to less than 2. They're saying which one specifically is less than 2. I'm just going to keep subbing in numbers for N. They did one time last year, 2022, leave insert for the blood one I have in my head. I don't know if that's true. They said if they use trial and error, the most they can do is 3. I'm not sure if that's fair or not. I think it was 3. I don't know if that's fair or not, but it's, you know, play it safe, I guess. So, sorry, I've just seen the time. Maybe I'm doing this too long. Sorry if it's too long. Sorry, guys. Sorry. Sorry, YouTube as well, because I don't know if they're going to be okay with this. Do I need to do something to upload longer videos? Do you have to be? I don't know. But what we would do is basically, what you can do is do, instead of doing TN, do TP, because that is what they're asking for. Put in P instead of N. And then in the formula over here, because again they kind of did a switcheroo where TN, SN, TN, unless again I've made a mistake because I'm like, you know, losing it. We would have this crap. And they want it to be less than 2, so most people automatically just do less than 2 and then do the maths, and I can respect that. However, the inequality freaks the shit out of people, so what I'm going to do is ignore it, and we're going to do equals, because we're going to find out not when is it less than 2, we're going to find out when is it 2, because then we'll know that it's just the next one will be less than 2. You know, if we find that it is 2 at you know 13.6, we know that the 14th swing will be the first one that's less than 2 then, because you have to just keep going to go smaller. So what I would do then is, it just becomes algebra. You notice that the letter we're looking for, P, is stuck in the power. So what that means is, if the letter you're looking for is ever stuck in the power, you have to use your log rules. Yeah, the one on top right of page 21, this guy, where it has the double arrow. And then what you would do is you would, what is it? It's log base A y equals x. Yeah, I think. And we have a scenario here that looks like this. So what we would do is we would say this is A, this is x, and this is y. And we would rewrite it out in this format. So what I'm going to do is I'm going to say log base 0.9 of 2 over 45 equals the p minus 1. Now, don't forget, on your calculator there is a button to do this. It's the one in the top right that has log and 2 boxes. Do not use the log that has no boxes. That is log base 10 automatically. That would not give you room to do 0.9. When you do that, what do you get? I should kind of remember this at this point. 0.9, 2 over 45. You get... oh, yeah, okay. I didn't remember that number, but I don't think we're done yet. We get this. But it's equal to p minus 1. You bring the p over and make it a plus. I don't know if that's right. I might have done something. You can check the market scheme. I just don't remember that number. That's my only issue. But it looks right. But it means that it would have to be swing number 30.55 to be 2 meters or 2 centimeters exactly. And if it keeps getting smaller, that means it must be the next one. So it must be 31 is actually what p is. Even if it was 30.00001, you still have to round in this scenario upwards, because we're finding out that it only goes as low as 2 when it hits 30.00001. If you went back to 30, it would not have hit 2 yet, so you have to go to the next one. I know it seems weird, but if in doubt, just try 30 and try 31 in here and see which one gives you a number less than 2. That's what you want to do. That's how you'd figure it out if you're stuck. Okay, hopefully that's okay. Again, it might not be okay, but I don't want to dawdle too much because I am aware this is going on for a long ass time. There's like 3 more parts to this that we can do. I don't know. Again, if you want to bounce, if you want to dip, fire away. Let me see though. I'm just gonna throw this down and just carry on, I suppose. And we'll see how he is like it. I don't know how long this is going to be. I'm gonna have a look and see. This might be honestly well too long. But there are parts you can skip. We'll see how it goes. So, if the length of the pendulum is 1 meter, show that the angle... Oh, this isn't sequences and series. Okay, so I'm going to kind of fly through this because it's not sequences and series. It's to do with, you know, the sector of a circle that's on page 10 of your log tables, 9, 10. And they will do it like, it'll be this, it'll look more like this in the diagram, and they'll have this bit shaded in. And they'll say this bit along the edge here is L. This bit on the inside is obviously the area. And it has 4 formulas. 2 for radians, 2 for degrees. They mentioned degrees, so we'd use the degree versions, which are... what are the degree versions? It would be 2 pi or theta over 360, I think. That could be wrong, but again, I'm not too focused on this one. In my head, I'm not actually doing this topic, you know what I mean? So my head isn't going to be... The area would be pi or squared theta over 360, I imagine then. Like, it's fairly simple for someone who's good at maths to actually figure that out, like, a lot easier. But I think it's just the length. I think it's just the circumference formula and the area formula by theta over 360, I think. But that's what we're going to use here. They want to show that the length, if they say the length of the pendulum is 1, that means like the rope that's hanging, the ball is hanging out of. So it'll be 1 either side, because if you think about it, if it goes out that way, the rope is 1. If it goes out that way, the rope is still 1. It's just in the wrong direction. Show that the angle theta of swing 1 is 26 degrees. And the reason we would do that is we know this is 45 centimeters. This is the part I warned you about. This is centimeters, this is meters, actually. That's crazy. So what we have to do is, if we're doing the maths, we have to treat the 1 as 100, or the 45 centimeters 0.45, as in we have to turn them both into centimeters or turn them both into meters. It depends on what you're into, you know, no judgment. But we know the length of the arc is the 45 number, so we're going to use this one, because we don't know the area, we don't care to find it, so we're just not going to use the area formula. So what I'm going to do is I'm going to say the L, the length of the arc is, I'm going to use it all as meters, so I'm going to say 0.45 equals 2 pi times 1 times theta over 360. And then you divide both sides by 2 pi. So it would cancel all of this crap out. And then you multiply both sides by 360. Because then on here it would cancel here, but here it'd be 360. Again, I'm skipping a few steps or cramming it all in together. Don't do this. Do it out properly. They want you to be able to, or they want to be able to see what you're doing. 360 multiplied by 0.45 over 2 pi. Close the bracket. 25.78. Corrected nearest degrees is 26. Cool. Hence, find the total accumulated angle that the pendulum swings through, i.e. the sum of all the angles it swings through until it stops swinging. I think we can all safely assume that's S infinity. We can use the S infinity, as I said before, because the OR is in between 1 and -1. It is 0.9. It is fine to use S infinity. And what they're saying is until it stops swinging, but that would just keep going and going and going and going and going and going. They say until it stops swinging. The way they have written the maths, though, the thing will never stop swinging. Because they've said it will always be 90% of what it was previous, 90% of what could be 0, as in no movement. It will always keep swinging in their example. Obviously, in real life, that doesn't work. But the formula for S infinity is A over 1 minus OR. Now, here's a weird thing, actually. In this one specifically, this isn't to do with sequences and series in general, but in this one, because the arc length was 90% each time, like it says in part A or at the start of the question, it means that the angle is also 90% each time. So here, because they care about the total accumulated angle, what we would do is we'd say A is 26, because for the very first one, for swing 1, we found that it was 26 degrees over 1 minus 0.9, which is 260, because the OR is still the same thing. If it works out for this kind of shape, if it's 90% at the bottom, it's 90% of the angle. That's what that means. And the last bit, I'm hoping when we do this that I can just be done and I just won't have to bother doing like any more shit. But I'm always afraid that I'm just going to find more shit. The whole point of this was that I would only cover the basic stuff, that you'd have at least like the basic tools and equipment to go into the actual exam and give it a shot. But I just keep constantly saying, oh, there's this, and then there's this, and then there's this. And it's a weird thing because I'm helping you guys a bit, but then I have to apologize because the fucking questions are so long. But hence otherwise, find the total distance traveled by the tip of the pendulum when it has moved through half of the total accumulated angle. Give your answer in centimeters, correct nearest integer. Find the total distance traveled by the tip of the pendulum when it has moved halfway through the total accumulated angle. So I think I did this a kind of complicated way when I first saw this. When I first saw this, what I did was I said half of the total accumulated angle is 130, and I found out using the SN formula from up here how many swings it would have to go through before it has covered. No, sorry. The SN formula from. I guess I didn't do it. I made an SN formula for the angle, and I found out how many swings it would have to go through to get to 130. Then I took that number for n and I subbed it in here to find out what the distance is. I think stupidly, it works out in a weird way that if they want half of the total accumulated angle, it would be half of the total accumulated distance. So all you would do is, it was kind of a trick where, in the same way what I said, it's 90%, if it's 90% at the bottom, it's 90% here. They kind of said if it's half of the angle here, it's just half of the distance. So what we have to do is do S infinity for the amount of distance it travels through, which would be 45 over 1 minus 0.9. If you follow the formula, it's the same formula, but it's just a different starting point, because instead of 26 degrees, it's 45 centimeters. And that will be 450, and then you divide that by 2 to get half of it, obviously, and it's 225. I can't remember if that's how they did it. They did some simple way to it. I'm going to do it my hard way, basically. You can leave if you want. Stop complaining. But they want to find out, is it half the total accumulated angle? The total accumulated angle is 260. Oh, I remember what it was. Is that what it was? That it wasn't actually 260, of course, because we rounded shit. Because it wasn't actually 26 degrees. It was 25.78. There was something like that. I can't quite recall. So let's say it was 2. It's just for simplicity's sake, and we're going to just say it's 260. So it'd be half, it would be 130 is what I'm saying. So we want the formula that was 26. I'm kind of losing. I'm starting to tire here, right? So I'm not being as clear, I suppose, as I'm kind of hoping to be. But the idea was that what we would do is we'd set up the formula like we would normally do, and we know we want to get 130 degrees because the total amount was 260, and they said half of the total amount, so it was 130. So then that would be one. I'm just going to skip a step, but it's algebra. Again, the power is the letter stuck in the power, so we're going to have to use the logs that I used before in the green up above, the top right of page 21. So that is going to be 0.1. You bring it up there, it becomes 0.1. It's going to be 13. 13 over 26 is a half. You're going to move to 1 over, it's going to be minus a half. So you're going to eventually, you're going to get this when you do all the maths. You use the log graph, and you'd say this. That's an n, just, yep. And you would say log 0.9, 0.5, and it would be the n is 6.5788, would say, right? Now that's not the final answer, that's just the n, that's the swing it would be on when it hits exactly halfway. So be on swing 65788. So in order to find out what the total distance is, I'm going to now do the SN formula for the distance. This SN formula was for the angles. That's why in position A I put 26, because the very first angle was 26 degrees. Here the very first distance on the first length of the arc was 45, so I'm going to slap that in. And it's still going to be 1 minus 0.9, but we know that the n is going to be the 6.5788. over 1 minus 0.9, and we can just draw all that into the calculator, and it's going to be, I hope I'm doing this right, in the last like 5 minutes, my head has just kind of gone foggy, like almost. I'm just kind of like, just spacing slightly, so I'm going to have to, either way, even if I was going to stop anyway, but even if I wasn't going to, I'm going to at the moment, just take a minute. I don't know how much of this, I don't know if there's any more of this I want to actually do either, but if there is, I'm definitely not doing it now. Yeah, when you put that in the calculator, you get 225. So this is the way I did it initially. This way is in the marking scheme, and I didn't even think of it. It's kind of a dodgy thing to do, because it's kind of like they're going, if you spot it, save you time. But again, I don't think that's just kind of mean to do in the leave insert. Okay, alright, that's it again. Hopefully I've covered everything. If I haven't, I'll awkwardly tag in another video like that again, but I don't want it to be that too long. I'll talk to you. Good luck. Any questions, of course, contact me in some way, and hopefully I will sort it out. Goodbye.